Good evening, everyone. My name is Brittany McKnight, and tonight I'm going to present my project, which looked at the effects of climate change on wildlife corridors in the Sky Islands. So just a brief outline of the presentation. First of all, I'm going to introduce the topic and provide information on the analysis setting. I'll talk about data collection and preparation, as well as the focal species that were used in this analysis. I'll go over my methods and procedures, present my results and discussion, and then finally end on conclusions. So habitat fragmentation is defined as the loss or separation of habitat across the landscape. It occurs due to a number of factors such as human-driven impacts, such as development and urbanization, as well as climate-driven impacts, such as climate change. And wildlife adapt to changes in the landscape by seeking out new areas of habitat. However, the only way they can successfully do so is if some type of connection exists between current and potential habitat. And this is often referred to as wildlife corridors. Wildlife corridors are linkages consisting of high landscape integrity that allow for the movement between wildlands. And here in the Southwest, habitat connectivity has become more of an issue as development increases. So this leads into my analysis, which was to assess the impacts of climate change on current and future wildlife habitat connectivity throughout the Sky Island region of southeastern Arizona and southwestern New Mexico. So the Sky Island region encompasses parts of Arizona, New Mexico, as well as northern Mexico. This term is used to describe the high elevation forested mountain ranges that are separated by low elevation expanses of open desert and grasslands. And this area is one of the most ecologically diverse regions in North America due to the convergence of temperate, tropical, and arid environments. So here is a map of the study region. You can see that many cities and towns are found within this area, as well as some major road features such as I-19 and I-10 that intersect the majority of the region. There are 21 Sky Islands in total, 13 of which are part of the Coronado National Forest. Data came from a variety of sources. The Sky Island boundaries, as well as a digital elevation model of the region, was provided by Sky Island Alliance, a local nonprofit group. Infrastructure data such as roads and rails, as well as political boundaries, came from the U.S. Census Bureau's Tigerline database. Land cover came from the Southwest Regional Gap Analysis Project. And habitat suitability scores for focal species came from the Corridor Designer Toolbox. And these scores were created by local regional wildlife biologists. And then the data was projected into NAD 1983 UTM Zone 12N, and when necessary, resampled to a cell size of 90 by 90 meters. So 8 species were selected. They were chosen for their distribution because their distribution covers the majority of the region. And they also represent a range of habitat requirements. Of these 8 species, 6 were mammals and 2 were reptiles. So here are the species. We have badger, black bear, kit fox, and javelina. And then their range and distribution, seen in green. And then the next species, Gila monster, mountain lion, mule deer, and the Sonoran whip snake. And then their range and distribution. So to obtain the final corridor map, several steps had to be completed. And these steps can be divided into 3 sections, including climate, habitat, and corridors. Climate was defined using mean annual temperature data for current and future conditions. temperature rasters had to be created, and this was done by dividing the study area into 49 overlapping squares that were equal in size. And then within these squares, an array of equally spaced points were created using the fishnet function in ArcMap. And then these points were overlaid with the elevation values. And elevation values were extracted based on the x and y coordinates of these points. And here are the 49 overlapping squares. Here is one of the fishnets within the squares, and when you zoom in, here are the points. And there were a total of 218,000 points within each square. From there, this data was exported into Excel, and it was formatted for input into Climate WNA. And Climate WNA is a free program that generates climate variables based on specific location according to X and Y and elevation values. Historic data is extracted, downscaled, and interpolated from PRISM data, which comes from local weather stations. And then future data is projected using global circulation models, which predict levels of greenhouse gas emissions. From there, the mean annual temperature data was joined back to the points. These points were converted into rasters, and then they were mosaicked. And so here are 49 of the rasters, and then mosaicked together is the 2011 temperature data. These values range from 6.6 to 22.9 degrees Celsius, or about 44 to 73 degrees Fahrenheit. And then the 2050 data, and the 2050 data actually ranged in value from 8.7 to 25 degrees Celsius. However, I represented them on the same scale so you could highlight the differences between them. Habitat suitability was defined by 4 factors, including land cover and vegetation, elevation, topography such as steep or gentle slopes, and distance to paved roads. These values were reclassified and scored from values 1 to 100, where 1 was the worst, 100 was the best, and these values were specific to the species. And then each of these factors were assigned a weighted value based on the importance, and then they were combined to create the habitat suitability model. And so here are the 4 factors, and then the equation that was used in raster calculator. And then here are some examples of the habitat maps. Areas in brown are where the species should avoid. Areas in gold are occasional use. Suboptimal are in the light green, and they range in value from 50 to 70. And then optimal habitat is in dark green, ranging in values from 70 to 100. From there, the temperature rasters and habitat rasters were put into a script for ArcMap called Climate Linkage Mapper, which models climate gradient corridors based on cost distance. And a number of factors were used. Sky islands were only linked if they were less than 50 kilometers apart, and their minimum mean annual temperature differed by at least 1 degree Celsius, which represented the linkage's capacity to continue to provide thermally suitable habitat. And the output of this was a resistance raster, which represented climate corridors through the landscape. And here is the output of that. This was reclassified and rescaled between values of 0 and 1. And then this raster was multiplied back to the corresponding habitat suitability raster to obtain habitat values within these corridors. So this model was then put into another script called Create Corridor Model. And although the Climate Linkage Mapper did create corridors on its own, I noticed that many of these corridors were exceedingly longer than the threshold value, and this is because the distance was based on Euclidean distance or straight line distance, and did not take barriers into in the landscape into consideration. So I basically had to repeat myself. And the linkages were based on the results of the climate linkage mapper. This tool was run 25 to 29 times for each species for each study year. And the output was several polygon layers based on various slices of the landscape. Only one slice was chosen for each species. And here's an example of one of those slices. The area in white is the optimal corridor. It goes through the least resistance in regards to climate and habitat. And then these other corridors are just potential areas that the species could use, but they're not optimal. So for all species, only the optimal corridor was used. From there, these individual species corridors were combined to form a single layer. And these are the corridors for badger for 2011. And then each of these species corridors were combined into a single layer for the year and converted into raster format. So here are the 2011 corridors for all species and the 2050 corridors for all species. Next, in raster calculator, these two rasters were subtracted to highlight differences. The results indicated that several changes occurred between study years. Some new corridors were added appeared in the 2050 data, and some 2011 corridors were lost. And also the path taken by some corridors changed, but overall many of these corridors remained the same. And so here is that change map. Corridors in brown are the ones that remain unchanged. Green are additions that occurred in the 2050 data, and red are 2011 losses. And so the results of this indicate that linkages were driven more through elevation changes, so low elevation linking to high elevation sky islands, as opposed to southern sky islands being linked to northern sky islands. And the linkages varied across species and study years. And these results appear acceptable based on the characteristics of the data. Although temperatures did increase, the change was about 2.1 degrees Celsius, so it wasn't drastic. And so the addition and losses of a few corridors seems appropriate. So in conclusion, designated corridors were intended to improve a species' ability to move across the landscape in response to climate change. Results indicated that connectivity can be sensitive to even minor alterations in the landscape. And the findings of this study have the potential to be used by local wildlife planners to make informed decisions to preserve native populations within the Sky Island region. Some future endeavors would be to investigate additional study years, such as 2080, and compare these resulting corridors to actual species occurrence data to see if they're similar or not. And then also, it'd be interesting to address specific locations in need of wildlife crossing structures, because many of these corridors did go through major highways. So my references. Any questions?
Did any of the climate data or the PRISM data deal with potential changes in precipitation compared to water?
I could have gone with precipitation, but especially when predicting future data, there were more uncertainties that came along with the precipitation as opposed to the temperature data. So that's why I just went with temperature.
You said you talked about barriers in there between the islands. What barriers do you consider?
So I considered urban areas. The land cover data included development as well as agriculture. It also included mining, and then just the basic land cover types. And then I digitized all the paved roads. So because the land cover data was only from 2006, so I noticed a lot of changes in the landscape, so I wanted to include these roads to kind of create more barriers that the 2006 data didn't incorporate. Great, thank you.